In this lecture, we are going to discuss about conversion of NFA to DFA. NFA can have 0, 1 or more than one move from a given state or a given input symbol. And NFA can also have null moves. But DFA has one and only one move from a given state on a given input symbol. We are going to convert this NFA to DFA. So this is the NFA which accepts the set of all strings whose second last symbol is 1. While converting this NFA to DFA, we have some steps. First, draw transition table. Once you draw the transition table, check the first row of the transition table, that is initial state. Now check the next state of that particular initial state. If there is new state, that is in next state, make that new state as new present state and continue this step until no new state is found. Now I am going to draw transition table for this diagram. In this example, we have three states Q0, Q1 and QF, where initial state is Q0, so I have written arrow followed by Q0, and final state is QF because two double circles are there, and I have mentioned here a star QF, and here we have two inputs 0 and 1. And now if Q0 is your present state, 0 is your present input, next state we don't have any next state, so it is empty. If Q0 is your present state, 1 is your present input, we have two next state, one is Q0, another one is Q1. If Q1 is your present state, 0 is your present input, next state is QF. If Q1 is your present state, 1 is your present input, next state is QF. If QF is your present state, 0 is your present input, we don't have any next state. Same for if input is 1, we don't have any next state. So I am going to write empty. So this is the first step for conversion of NFA to DFA. First we have to make transition table. We are going to check the first row of this table. I am going to rewrite this again over here. Now check, is there any new state in this next state part? One is empty, another one we have Q0, Q1. But we have one state that is Q0, and so this is new one. So I am going to make this new state as present state. So it is Q0, Q1. So I am going to write union of Q0 and Q1. Now I am going to find union of this Q0 and Q1 like this. Put is 0, then here it is empty and here it is QF. So the union will be QF. Now we are going to write union of Q0, Q1, and if input symbol is 1. So Q0 union Q1, and if input is 1, so next union is Q0, Q1 and QF. So it will be Q0, Q1 and QF. So I am going to write this over here. Now check, is there any new state? So QF, it is new state, and again we have one more new state Q0, Q1 and QF. So we are going to make this two new states as our present state. Now I am going to make this QF as my present state. So QF, the next state is empty if input is 0, and if input is 1, next state is empty. So I am going to write empty over here. There is no new state over here. So I am going to proceed with this one Q0, Q1 and QF. Now we are going to write union for Q0, Q0, union Q1 and union QF if input is 0. So it will be QF. because if input is 0, the next state is empty. If input is 0, next state is QF. Input is 0, next state is empty. So empty union QF union empty, it is QF. Q0 union Q1 union QF. If input is 1, so next state is Q0 Q1 union. So along with that we will add QF and empty. So it will be Q0 Q1 and QF. Now check, is there any new state over here? Q0 Q1 QF already we have, QF already we have, there is no new state. So now we are going to find which one is final state. So here which one is final state? QF is final state. Wherever QF is there, that is final state. So we have two final state over here. This one is final state and this one is final state. So this is our DFA. For each input we have only one next state, hence it is DFA.